Hello, my name is Helen Kardiasmenos, and this is my presentation for my action research project, Teaching Girls to be Leaders in Technology, Plugged into Unplugged. A little bit about myself first. My name is Helen Kardiasmenos. I have three amazing roles. I'm fortunate enough to be the junior school technology teacher at Presbyterian Ladies College, Sydney. And in this role, I work primarily with students and with teachers in making the digital technologies outcomes come alive from the science and technology curriculum. I work with teachers in upskilling them in how to integrate technologies into the curriculum through a team teaching approach. I'm also the Sydney Project Officer for the Computer Science Education Group, which is part of the University of Adelaide. In this group, I work with teachers and I upskill them in using technology in their classroom. So I run a lot of professional development and workshops and webinars with teachers on anything from computational thinking, coding, augmented reality, AI in the classroom, cybersecurity, etc. And I'm also a sessional academic with the Australian Catholic University and Swinburne Online University. And in these roles, I work with pre-service teachers in teaching them how to teach technology in the classroom, particularly in a K-6 context. Now, the very heart of my project finds its roots in our school ethos as part of the pursuit of wisdom, process of inquiry or spirit of inquiry that we at PLC follow. In this role, in this process, we encourage our students and our teachers to pursue that knowledge or that wisdom through truth and through discipline and challenge. And also to think about the role that technology plays as a tool as part of that pursuit of wisdom. Now, my problem of practice stemmed from my roles as a specialist technology teacher and a technology trainer. And one of the things I noted across my work is that students and teachers tend to get quite anxious when integrating technology in the curriculum, and particularly when they hear the words coding. Often my students and teachers feel that when we're talking about coding that we're going to code the next Facebook in the next lesson, and that's not the case. So my focus is around how to help teachers and students better understand coding concepts and understand that coding is a transferable skill within coding projects and in the classroom and the world beyond. So looking at coding in the framework of a transferable skill, of a skill of tomorrow that our students and teachers will need to be successful, that it's cross-curriculum and cross-discipline and cross-occupation, and a skill that they'll use in school and beyond. And this ties back into Michael Fullan's 6 C's of 21st century learning. Fullan proposed that there are 6 C's that students and teachers essentially need in a classroom to be successful learners. And these things are as far ranging as communication to citizenship to the inner self and the outer self. Things like critical thinking and computational thinking, problem solving, collaboration, working with others, developing resilience through character education, and being creative using a design process. My research is underpinned by this framework, and within the scope of research, the students all participated in different activities and learning experiences where they tapped into different aspects of this framework. And this again ties back to our curriculum. In the primary school context, we have a new science curriculum in K-6, and essential to that curriculum is the teaching of digital technologies. Within that scope, we focus on developing transferable skills. So the focus isn't on creating the next generation of Googlers or coders. The focus is on developing skills of problem solving, of computational thinking, of design thinking, and of systems thinking. So those transferable skills, yet again, with the idea being that students are now developers and creators with technology rather than just the focus being students as users of technology. And the same rings true for teachers. A big focus in the new curriculum and in our new pedagogy is trying to align understanding of digital concepts and the 6 C's of 21st century into what we do in the classroom as primary practitioners every day. So defining feature of my research project is that it's grassroots research project, and it relates directly into digital technologies integration in the classroom and in the practice of everyday primary school teachers. It looks at strategies for incorporating coding and incorporating those computational thinking frameworks for everything that we do within the K-6 curriculum, and particularly by tapping into activities that classroom teachers can walk away and apply tomorrow in their literacy or numeracy activities. At central to this is the TPAC framework. Now, the TPAC framework looks at how meaningful technology integration can occur in a classroom. And it proposes that there are 3 elements that come together to ensure that that meaningful integration occurs. On the one hand, we have technological knowledge. So within this particular research project, the technological knowledge aspect came from the coding concepts and the ideas of coding and game design and user experience. We also have content knowledge. So this is the aspect that the teacher brings about the specific content that the students are exploring. In this case, the content knowledge of this particular research project and unit of work came from the specific learning outcomes the students were working towards around learning about birds and also learning about procedures as part of their writing. And then there's also the pedagogical knowledge. So how these 2 factors are applied in the classroom. In this particular research project, we've taken the pedagogical approach of kinesthetic learning, and then within that, use teaching strategies of unplugged and plugged pedagogies to explore this technological knowledge of coding concepts. So the primary objective of this research project is to look at the effectiveness of unplugged and plugged teaching strategies for students' understanding and application of coding concepts within the curriculum. Subsequent goals of this research project was to look at how students were able to develop those transferable skills through these unplugged teaching strategies. So things like communication and collaboration. Finally, the subsequent goals all revolved around the pedagogical approaches to teaching coding, particularly around upskilling classroom teachers with technology integration and looking at how unplugged strategies can work across literacy and numeracy domains, as well as computer science. At the conclusion of this research project, the students were charged with a design task to create and code a backyard birds game in Scratch. So there were 3 phases of research that occurred as part of the process. In phase 1, students were introduced to the concept of gamification, and we really deconstructed what is a game, what are the features of a game, what is an unplugged game or a non-digital game, and what are digital games. And students had the opportunity to explore all of those things. At the conclusion of phase 1, all the students completed the same coding concept assessment task. Now, this assessment task or test is to be repeated twice throughout the research project and essentially ascertains their understanding of coding concepts at a broad level. After the completion of this coding concepts assessment, the students moved on to phase 2 of the research. In phase 2, we really deconstructed the coding concepts. We looked at what these were and how these function within a computer program, but also more broadly in everyday life or in other activities. Now, this is where the divergence happened. One of my classes, which is my 4G class, they were my test class. So they undertook the unplugged teaching strategies and then the plugged teaching strategies. So they explored these coding concepts in an unplugged manner and then in a plugged manner. And then at the conclusion of that, they completed the coding assessment from phase 1. They completed it again to conclude phase 2. On the other hand, my 2 other classes, 4L and 4R, were only exposed to plugged teaching strategies. So they only explored coding concepts in a plugged concept. Now, just a key thing to note here is Initially, when the research was planned, the coding aspects were scheduled to take place in the classroom using robots and other equipment. However, as a result of COVID-19, that all had to be modified. So all of the plugged activities the students completed were all completed online using online digital tools. At the conclusion of the plugged aspects, students then completed a coding test or assessment. So following this, we moved on to phase 3 of research. In phase 3 of research, the students applied their coding understanding or their coding concepts. And they did this by designing and making a game in Scratch about birds. Now, all the students undertook the same design process. They all started by planning out and designing their game on paper. They then went on to code and create their game. They then played each other's game and gave each other some feedback on gameplay, user experience, and some of the coding concepts. And then they had an opportunity to redesign their game. At the conclusion of this phase of research, the coding concepts assessment was administered for the last time to end the research process. Now, just to clarify, unplugged teaching strategies in computer science involve using non-digital technologies or no technology. So they're often hands-on kinesthetic learning experiences that include role play, collaboration, communication, with the ultimate goal of creating and building. Only 4G undertook these teaching strategies, and there were 4 of these that we went through. The first one was paired programming, and this involved one student taking the role of robot and the other student taking the role of programmer. The programmer would code or program the robot using the coding cards, and the robot would have to follow the code or the instructions given to them by the programmer. A second activity that we did were barrier games. So in this particular activity, the students, again being programmer and robot, would have the opportunity the programmer would code the robot to colour in squares on their grid to see if the robot could create the picture that the programmer had on their end. So it really was a very strong communicative activity, a literacy-based activity. There was a lot of language. We had a set coding structure, as you can see here, that was consistent for both programmer and robot, with the goal of trying to create the same image. Very similar to the game Battleship. Another activity we did was around creating and following algorithms by making paper planes. So in this activity, students were paired and grouped in groups of 3. The group would write a pseudocode or algorithm in plain English or a procedure on how to build a paper plane. Their procedure that was then given to another group who had to follow their procedure in order to make the paper plane. And the final activity we did was many meanings variables activity. So this activity explores, is a literacy-based activity and explores variables in language. In this activity, the students were given a story, and the story had some placeholder words or categories, as you can see, weather, boy's name, animal, etc. And what the students had to do is brainstorm different words that would fit into that category. They then had to read the story back with the different combinations and talk about how the meaning changed based on whatever word was in the variable placeholder. Very much like variables work in a computer game. Now, when we're talking about plugged teaching strategies, we're talking about using technology or software or digital tools. And often with plugged teaching strategies, there is a universally accepted coding language. So it may be text languages like HTML or Java, which are used to code web pages, or Python, which is used primarily with robots, or block coding, which is what we use in the primary school context. Now, all 3 classes use these teaching strategies. And again, due to COVID-19, these were delivered online. So platforms like YouTube and Google Classroom were used to deliver content, and Seesaw was used to share content, so students could share their work on Seesaw. And things like code.org and Scratch and Pencil Code were coding platforms the students used to experiment with plugged activities. So some of the activities we did, we used Total Code, for example, to code different kind of shapes. We used Scratch to code games and different digital animations. When we did have the opportunity to return to school, students were able to code robots. So we used the Dash robot to code different shapes and mark out different places on the floor that Dash had to then travel to. So what did we find after the research? Well, in February, when we conducted the first coding assessment, we found that 43% of 4G students, now these are the students that were exposed to both unplugged and plugged teaching strategies, scored 40 or above in that coding assessment, compared to 40% and 39% in 4L and 4R. So this is our benchmark. By July, after the conclusion of the research and the exposure to the unplugged and plugged teaching strategies, we found that 83% of 4G students scored 40 or above in the coding concepts assessment in July. So this was after the application of those unplugged teaching strategies. This is a great result compared to our students that just were exposed to plugged teaching strategies in 4L and 4R, who received scores of 79 and 69 respectively. We also did a miscue analysis on the students' completed games. And we found that the green data, which is 4G, demonstrates that our unplugged students were able to use more coding blocks across all of their games. They were able to use them correctly, and they were able to use a variety of different, particularly higher order coding blocks like variables or broadcast blocks. We also found that our 4G students were able to code multiple sprites. So using variables, using broadcast blocks, using our branching blocks, and coding more sprites or multiple sprites or characters in their games. In contrast, our 4R and 4L groups who only had exposure to plugged activities, we found a limited use of variable blocks in their games, and we also found little to no branching was used or broadcast blocks. So those higher order blocks were missing. We also found that those students were only able to code 1 or 2 sprites. When we do a side-by-side comparison of the students' work, we see that our 4G, which is located on our left, we see the use of the branching, we see the use of the variables, and we see the kind of more complicated stacks. Over here in 4R or 4L, which is on the left-hand side, we see shorter stacks of code. We don't see the use of variables. We don't see multiple sprites. So what does this mean? Our overall findings, we can then ascertain that the unplugged strategies were more effective in helping students to understand coding concepts, particularly the more complicated concepts like variables and branchings. They were also able to apply coding concepts in their games and design more complicated games. Where to next? One of the things I would like to do with this research is extend on it and apply the same research procedure to a different cohort of students or even students at a different school to see if that will affect the results of the unplugged to plugged teaching strategies. It would also be interesting to do a closer analysis of the teacher perceptions of this, and particularly how teachers are able to then apply some of these unplugged teaching strategies in other key learning areas. And finally, looking at the relationship between looking at these unplugged teaching strategies and teaching text coding. Thank you for your time. If you do have any questions, please ask. You can contact me via Twitter or on my email. Thank you.